Oh, hey, Nicolai.
Good to
Hi
have you.
there.
Hey, how are you doing?
I'm doing fine, given the circumstances.
Absolutely.
Yeah.
So, very quickly, just below here, you can see there's a ticker, and it's going visit ordertalks.org/tickets, and also somewhere up here.
Am I going the right
Here
direction?
somewhere. Yeah, I think up there is a donate button, which I've not noticed until now. So I've been telling everyone to go to this. But if you click donate, then you can help to raise money for the World Health Organization Solidarity Response Fund, which we're all trying to do today. Obviously, we're trying to learn loads of stuff, share loads of things as well. But if we could also find a way to, if you've got anything at all to give that will help victims of coronavirus COVID-19 outbreak, then it'll be really super appreciated. So with that said, I'm going to hand over to Grace, who's going to bring Nicolai in.
Fantastic. Thanks so much. Hi, Nicolai. Welcome. So you're going to be presenting Java after 8. Is that right?
Yes, that's
fantastic. So if anyone is interested in learning about, what are the advantages of moving from Java 8 to sort of more recent versions of Java all the way up to 14, then this is the talk you need to be watching. Get on this stream. Yes. Right. Do you have a screen to share for us, Nicolai?
Yes. Don't I yet?
Fantastic.
No, I don't. Let me see.
If you share it for me, I will add it to the stream. And if anyone's got any questions, please keep posting them to either Slido or our Slack channel, and we will ask them in our Q&A afterwards. But with no further ado, we're bang on time, so I'll let you start. Over to you.
Thank you, Grace. So here we are, Java after 8. I'm Nicolai. I'll talk about myself later if we have time left, because we only have 30 minutes. And to quote Brian Getz, I prepared way too much, so I'm going to talk way too fast. So the plan for today is we're going to start with the Java 8 code base, and we're going to take it all the way to Java 14, and you're going to see how much changes. I'm not going to explain these features in detail. There's not enough time for that. This fills entire courses. I'm just going to show you a bunch of the features and just very quickly in a spotlight so you see how much the code evolves over time. If you go to slides.codefx.org right now, you will see on the top right corner Java after 8. And if you click it, you will see the very slides that I'm showing here. And also contains links to a demo code base, which is the one I'm working on here. And then there's one which presents these features in a little more meaningful way and not just like banging them. OK, let's start with Java 8. That's where we're going to start with the code base and just quickly look at that. Java 8 was released in March 2014, which by computer measurements is ages ago. And free support by Oracle ended, but you can still get free support from under the roof of Red Hat. They're maintaining the Java 8 update project until June 2023. And it's a good release to be on. It has a solid feature set, good performance. It is stable, and it does see occasional backports of newer features. But at the same time, it does get dated. And you can tell with each released Java version, it gets dated more and more. So there are many new language features, and many new and improved APIs and JVM features. And even though a few of the JVM features get backported, most of the other things obviously don't. And in certain cases, you can expect better performance as well. And so, as I said, we're now going to start with Java 8. We're going to look at a Java 8 code base that hopefully everybody agrees looks kind of OK. And then we're going to make it better. So yeah, let's do that. We're going to spend most of the talk on this Java code base right here. So I'm going to quickly walk you through the project, and then we're going to start changing it. So what does this project do? At input, it takes blog posts, which are markdown format, so something like this. Right? This is a blog post. Here's the text. And up here, you have some metadata. Front matter is what it's called in markdown blog posts, like the title and some tags and some dates and stuff. And this is basically a recommendation engine. It takes this as input, and at output, it generates a JSON file, which, by the way, should be somewhere down here. No, not yet. But yeah, we'll see that later. So it generates a JSON file that basically says, given this article, these are the 3 articles to read next. And how does it do that? It's very straightforward. It reads these files. And for that, it uses the classes that are in this package here. You see the slug class here, which is basically like a wrapper around the string value. Right? This is the slug here. And then you have the, well, you don't need the class for the date. We already have a class for that in Java. There's a class for the title and for the tags. And you can see a good correspondence between the front matter here and the classes here, and then the article is, of course, the front matter plus, all that stuff down here. Right? You can see that it has a title and some tags and a date and stuff like that. And then we walk through a couple of classes that are just going to show you the packages very quickly. There's a genealogist here, which, because this is about relationships, I figured I'm going to use genealogist terminology here. So this is an API. So this is the API. There's a genealogist, which just takes an article and compares these. And then we have a genealogy here, which puts all of these together. It basically takes a bunch of genealogists, which can compare individual articles, a bunch of articles, and a way to weight these results. And it spews out a bunch of relations. And those relations would then be given this article and this other article, what score did they have? And that's the input to the recommendation engine. And in the end, the recommendation would be here are a bunch of articles. So here's an article, and here are a bunch of articles that are recommended for it. Right? So fairly straightforward. The main class binds all of this together. And we're going to quickly run this. Let's go here and quickly. There we go. I'm using SDKman for this, which I can only recommend. Look up SDKman if you don't use it already. It's really great if you work with different Java versions. And if we now run this, we're going to build this with Maven in the background. This is what it's doing right now. And then it's running the program 10 times, so we can get a little bit better of a performance impression. Right? This is not a proper performance measurement. But still, it takes about, let's say, 0.9 seconds to run this. And the code base, this may be more important, has about 1,650 lines, so 1,654 lines of code. And the words and characters, maybe not that important, but we're going to keep those in mind as well. And now we should see, the recommendations are here. You can see the output here. So for example, if you've read the article Java 8 as the optional strict approach, then also read these other articles, because apparently they're related. That's where we are, Java 8. The code base uses lots of stream pipelines, optional, that kind of stuff, and a bunch of other APIs. And now, as I said, we're going to do the upgrade. We're going to move to Java 9. So what do we do for the Java 9 upgrade? Probably you heard that it's a scary update to make. I'm one of those people that occasionally say that. But really, it doesn't have to be hard. Let's switch to Java 9 here. Now let's run it. And there you go. That was the Java 9 update. See, it's not hard. You just need a project which has 0 dependencies and just 1,600 lines of code. And there you go. Then it's very easy. So now we're on Java 9. And the first thing I would like to show you is the module system. But as much as I love it, going into that takes a while. And I'm going to do a lot of editing in a couple of small files. And we just don't have time for that today. But if you go to that repository, you will see an individual checkout, which does just that, right? So if you go to the Git history, you will see that there's a branch here, upgrades. And that branch contains these commits, which say use upgrade to Java 9, use the module system, use collection factory methods, use optional OR. So you can see all these individual features and the diffs that were needed to make them work. So we're going to skip the module system as much as it pains me. And we're going to do something which is much simpler, but maybe even more fun. We're going to have a look at these arrays else list calls. These are quite common in this code base. They're common in tests. They're common even in the regular code. And what they do is, well, they want to take these two items and put them into a list. And arrays as list is the best kind of way to do that, even though it's not a good way. And since Java 9, we can go with list.of. And that's the collection factories that were introduced in Java 9. And basically, every arrays as list, like all of them, can be replaced with that, right? So these all become much saner and much more straightforward to find, right? List.of makes more sense. You're probably going to look there much more than if you're looking for, well, if you want to create a list, then to think about, oh yeah, there's this arrays as list thingy. Now, what else? You cannot only create lists like that. You can also create other collections, also maps. So let's have a look at this here. For this test, I need a couple of these weights. A weight it needs a relation, whatever that is, doesn't matter too much, and a weight, which is a number, right? So it maps from relation type to a double, and I need that for these tests to work. So what I do the thing that you have to do here, right? You create the list and the map, and then you put stuff in, and then there you go. Do you know what? With Java 9, we can instead do this. We can say the weights are this, and now it's map.off. And oh, sorry, there's that. And now we're just going to say multi-line editing here. That's that. So we create a map of these two pairs, or basically key value. And then, wait a moment, like we just need that map to put it in here. Now this is a one-liner. We can inline this. I'm going to use the IntelliJ inline function. I'm going to inline that here. And then I might realize, look at that. I don't need a constructor after all. And if you've ever had to create static initializers just so you could populate a collection that you have in a static field, then you know the pain of like feeling like I have to create this piece of code that all it really does is puts two things into a map or into a set. And now you can get away with this and put this into a one-liner. If we properly format this, right, something like this, you could even read it well. There are a couple of more of these places all around the code base, but I'm not going to go through all of them. Let's instead go to optional. Optional also got improvements. We're going to see that best. I think one of the places is here. So this is the configuration that's being parsed into an output file. The configuration, contains a path to an output file, the recommendations JSON that I showed you. And if the configuration does configure the output file, then I want to do this, and otherwise I want to do this. Now, this is an optional because maybe there is no file configured, and because this was written on Java 8, I still have to do this if it's present, then do this, or else do that. Because in Java 8 you had an if present method, but you didn't have a way to say, well, what do I do if it's not present? And now we have that. It's called if present or else. You're going to say, I'm going to put a lambda in here. Sorry, that's probably not a good way to write file. And now we're going to have an else. And the else branch doesn't have any input, right? Because the optional is empty. And so we could do this. So if you like these functional approaches, then this will make it possible to have an else branch that is also functional. Let's go to utils. So what do we do here? Utils is, you saw the output, right? When you ran this output, process ID in major Java version. Figuring out the process ID is not trivial in Java. So the problem with that is that, not utils. Where am I going with this? Process details, sorry. Getting the process ID is not trivial. So there are a bunch of different ways to do this, and they might fail on different operating systems and different Java versions. So what you want to do is you want to implement a bunch of these, and then you want to figure out which one worked. So basically, you want to run this one, or you want to do this, or you want to do this. Basically, stop once you found something that worked. And the way to do this in Java 8 is you run, right? So you execute one method, and then you get back an optional, and then you check if it's present, you're done. Right, you return this. But if it's not present, then you do another call, and then you do another call. And these chains are really annoying. What you would like to do is to recover from an empty optional into a non-empty optional. You can do something like get pit from, you would think, hey, wait, can I do this? Can I do get pit from an xbean or else? Yeah, but then you have to provide a specific value. But I don't have a specific value here. I just want to try a next thing that also returns an optional. And we can do that now. The method is called or. With or, let's use correction factories. With or, we can say do the first optional bearing operation, and if that didn't work, try the second optional bearing operation. And if that didn't work, well then try the third one. And you see where this is going. To no one's surprise, there will be a fourth one here as well. And I forgot the columns. Right. This is so damn useful. I wrote my own utility method for Java 8 to do this, which I can give a bunch of suppliers of optional, and it gives me the first non-empty optional back. So that's pretty cool. That makes this code much shorter and much easier to read too, right? We didn't just spare lines. We also made the code more expressive because this very clearly says what we want to do. We want to do this or that or that or that. But Java 9 didn't only change a bunch of small APIs. It also provided a bunch of new ones and extended new ones. And the thing is, we don't even need to do this anymore, because get this. What we can do is we can say process handle current process ID. Amazing, huh? True rocket science right there. It took Java like 20 years to get a good way to find its own process ID. And the same is true for the other part of this API. By the way, no, all of this goes away. This is all garbage now. And the same is true for the get Java version, right? So here we take Java version and then we parse it. We check, is it one dot or is it just a dot? Or, you know, maybe we just try to parse an int and things can go wrong. And all of that also became unnecessary. You can just say, I think it's runtime.version. And now we could say, well, it's not called major anymore. I'm not going to go into that. I'm just going to use major here. And there we are. This goes away now too. So this entire utility class or process details class, totally superfluous. Nobody needs that because now Java has proper APIs to find process IDs and its own major version. There's also a stream improvement, but also that takes a bit to go into. I don't want to show it in detail, but I want to explain quickly what it does. Where do I find it? Right, it's article factoring. So as you can see, I have my notes right next to me because no way can I remember all of this. Let's have a look at this method. It takes a list of string, which is a list of lines from the markdown file, and it's supposed to extract the front matter. Let's see the front matter. Remember, somewhere down here there was a markdown file. It looks for these lines. So it goes until it finds the first 3 dashes, and then it continues going until the second 3 dashes. That's what it does. And with a for loop, it looks like this, which is not really easy to read. Let's have a look how this looks with the new drop while and take while. Because with Stream API now gives you a chance to say, another stream, the diff is a bit noisy. We're focusing on the right-hand side here. Ignore the colors for a second. Wait. Oh, you know what? Let's do this differently. Let's check out the final version. I can show you here. There it is. What we're doing now is we're saying start with these lines and then drop lines until we find the first front matter separator. Then skip that one because we don't want to have that front matter separator. And then take lines until we find the second one. Basically what this is skip until, because you know skip, right? Skip takes a specific number, and this is skip until this thing becomes true or false. It's a mind bender, some of those. And this is then, the first one is skip, and the other one, what's the other one called? Limit. Maybe this is limit until, never mind whether it's until. So basically what I'm saying is, the first one is skip with a predicate, and the second one is limit with a predicate. And that didn't exist before, and Java 9 introduced them. And that's going to make a bunch of stream pipelines, make stream pipeline viable in a situation where it wasn't before. So that's a really great improvement. So what I just checked out is the final version, which contains all the Java 9 fixes. Oh, we're already on Java 9, right? So, but now we can run it. And if we do, we'll see that, unfortunately, the runtime increases a bit. You see here, right? So we lost about 0.2 seconds, roughly, which is quite a lot. But we dropped 100 lines of code. That's not too bad. And these two things are mostly unrelated. So the increase in runtime is because of some other internal changes. Yes, so that's Java 9. Now let's go to Java 10. Once again, the update. So the update to Java 9 that I just made, I admit a real-life update may take a bit more time. But going to Java 10 really usually just takes as much time as I do here. You may have to update some dependencies. And what's maybe the biggest feature in Java 10 is var. And I know var is a testy discussion. Now you want, can I use var everywhere, or do I not want to use var everywhere? There's a a good discussion to be had about that. There's some good advice by the Oracle people. But here, let's have a look at this line. It says config config is config create. Okay, I think we can agree that this is clearly a config. And this is a genealogy. And this is a recommender. So I think in these cases, it's very straightforward that, well, this is what this is, which is what this is. Now here we can already start to argue. Can I use var here? I don't know. I have an opinion on that, but let's not go into that. But Java 10, if you use var all the way, it really changes the code base quite a lot. And depending on where you are on that, you might think it's to the better or for the worse. I think in many cases, it makes it better. And actually, I would use var here. So there you go. Another cool thing is that you often use collectors, right? So let's say I just randomly put up some collector. We use a collector to a map. And what do we do with this map? It turns out that we get from it, but we don't actually change it anymore. And I think that's quite common. Quite often, the result of a stream pipeline should really be should not be modified anymore. Well, not should not be, but you don't want it to be modified anymore. You think like, okay, I put this result together. I'm not going to hand this around, but I don't need it to be modified anymore. And there's now a collector which is called to unmodifiable map. And the same exists for to unmodifiable set and to unmodifiable list. And they create the same instances that list.off or set.off would create. And also, what we have now is a copy constructor, basically, or copy method. So here we get a map, and we do the good thing here, and we defensively create a copy. And then also we check whether either of the values was null, because I don't like null and it shouldn't be in there. What you can do now is, since Java 10, you can say map copy of that other map. And then not only do you get A, an unmodifiable copy, but B, you get these null checks, and C, as a bonus, if this already was one of these unmodifiable maps, then you get the same instance back here. So then there is no additional wrapping, which is pretty neat, because if you use collections.unmodifiable, then you will get an additional wrapper every single time. And that's already pretty much all there's to it on Java 10. I'm going to skip application class data sharing, because that takes way too long to go into. And I broke because I didn't update to Java 10. Okay, Java 11 did not bring a whole lot of big features. It didn't change. It didn't change the language at all, and most of the API changes were rather small. I just want to show you one thing that I think is pretty cool, which is here. Do you see this? A filter that checks whether something is not empty, specifically a filter that checks whether something is not the case, right? So you're basically inverting a Boolean check here, which is a bit unfortunate, because you could do this otherwise. If you were not negating, you could do this. And now you can. You can say predicate not, very small method. It's a static method that is on predicate. And now I can say predicate not, or, oh, wait, I didn't go to Java 11, actually. I kind of have to do that to make use of those APIs. Yeah, on Java 11 now. See all these updates, piece of cake. If you add a static import, it says filter if not empty. Well, I smuggled in the if there. But filter not string is empty. I think that's at least as readable as what was there before, and you couldn't accidentally miss the exclamation point. So I think that's a good improvement right there. Now, if we go to Java 12, then the big headline feature in Java 12 is switch expressions. But for the life of me, I couldn't force a switch into this code base. It just doesn't work. There's nothing to switch over here. So one of the coolest features that Java introduced, I can't even show you here. That's really too bad. There were also a couple of other cool things that were added. For example, there's a teeing collector. Like with drop while and take while, not trivial to explain, or not trivial to show in code, but the high-level explanation, I think that's fairly easy to grasp. What a teeing collector is you give a teeing collector three things: one other collector and another other collector. And what it will do is it will take any stream element and pass them to both of these collectors. And the third thing you give it is a way to combine the results of the collectors. Okay, let's see the result of that. So that's Java 12. That's here. And now we go to relation. And we're going to see that somewhere. Aggregate. Towards row. Where is it? God damn it. Am I mixing something? Keying? What the hell? Yeah, it looks like I want to replace this. Shouldn't this be in here? Oh, I see. Let me quickly check. I checked out the wrong. I'll fix this in a sec. I checked out the wrong commit. Well, I can check out the right one, though. I think I will manage to do that. That would be this one. Yeah, that's the one. Now this should change. There we go. Okay. So there's a keying collector here. Once again, we have to make the update here. Already have the update. Oh, yeah. IntelliJ just took a second. Okay, so what does this keying collector do? This one is already in advanced use, but what it basically does, it passes off to this collector, and then to this collector, averaging double, which already exists. And then it takes the result of both and combines that. And that's really handy. If, for example, you have a collector that does averaging double, and there's another collector that does a sum, both of those exist, you can now say, oh, I have numbers. I want to have both of these results. I want to have the sum and the double, and the average. So, you pass off to both, and you get back a result, the result of each collector, and then you can combine them. So that's pretty cool. Okay, let's go to Java. Let's go immediately to 13. Sorry, 14. Let's go to 14. I want to show you two more language features. One of them is a preview feature in 13, that's text blocks, and the other one is a preview feature in 14. So, text blocks. We are creating JSON, right? And the thing is that creating JSON, you think, why, can I use a library for that? And yeah, sure, you can use a library for that. But on the other hand, do you really want to use a library for just these couple of lines of code? Nah. I mean, it's really all you would replace. So, I put this together on my own here with like string concatenation and tabs and a new line, so it looks good. And all of that is, of course, horrible to write out. And I think there are a couple more cases where you want to write nicely formatted multi-line strings, but it's just hard to do that in Java right now. And with text blocks, we can do this. Look at this. It's actually readable. You can, oh, this is JSON, right? It looks like JSON. I mean, there's a placeholder here, but on that, it looks like JSON. That's really nice. And now the single quotation mark is no longer special because it's not a delimiter. So that means you don't have to escape it. You still can escape and have to escape all kinds of stuff. You can add tabs and new lines. So escaping still works. But you don't have to escape the single quotation mark anymore, which is really good. And of course, the headline feature of Java 14. Clearly, that's records. I'll use it here. Actually, all of these classes become records. Straightforward. They're all just a wrapper around something else, right? I want to do good domain-driven design, and I don't want to have just strings running around. Everything like a description is a string, and a title is a string, and then you have a constructor with 5 string arguments. Now I want to have a proper type for a description. But then you end up with these classes, which just are like take tons of lines of code for getter and constructor and equals and hash code and toString. All what you really want to say is, look, I have a small class which just wraps around a string, and that's it. And with Java 14, you can finally do that. And even though there's tons more in 12 and 13 and 14 that I had to skip, and there's, if you take a look at the slides, then you will see, let's just pick some example here in Java 10. I want to show you all of this, which I didn't. But then there's even more that I didn't even plan on showing you. And that's the case for all of these Java versions, right? So even with what I didn't show you right now, but it's in the code base, there's even more stuff that didn't even make it into the code base. So what I'm really trying to tell you here is that, we should have a final run, though.
Nicolai, we're going to have to wrap up in just 1 minute, so we have time for Q&A.
Yes, OK. Java 14. New Java versions. They're awesome. Now let's go to Q&A. Sorry.
Okay, great. No worries. I mean, one of the questions that I think might solve a lot of this is there a URL for the code so that they can access it outside of this session?
Yes, it's in the slides. Go to, and I will tweet it later. Go to slides.codefx.org, and then you'll see it in the top right corner. And there's a slide deck. And in the slide deck, there's links to the slides.
Fantastic. And if you could post that in the Slack channel, that would be really helpful.
Yes, I will. Definitely.
Fantastic. And then we have another one, which is, we've got a question from someone anonymous saying, should we go to the latest, so version 14, or stick with only LTS ones?
That depends on your project. If you're confident that you can update your code, your dependencies, and your tools every 6 months, then I would go with the latest releases. If you feel like that may be too big of a risk for whatever reason, then stick to LTS. Just one last word for me. We just lost a quarter of the code base over these migrations. And I would say we lost no expressiveness whatsoever, quite the opposite. We made the code more expressive, not denser, but more expressive. And it's just 75% of the code. And it got a bit faster too. Look at that.
Amazing. So if anyone's not convinced, hopefully that's convinced you. Any other questions that I didn't answer that people want answered by Nicolai, please head over to the Slack channel and he'll be able to answer them in the next meal break, which is coming up.
Okay.
Great.
Yeah, I'll see you there.
Thanks, Nicolai. Appreciate it. Bye.